welcome Victor Perez. Victor.
Can I have my computer screen, please? Okay. So thank you, everybody, for coming here today. I'm sure you came because it's raining outside and you didn't have anywhere else to go. But you know, I'm going to torture your souls with my color thing. So I'm going to talk about the brief and dangerously oversimplified fundamentals of the ACES workflow. Why dangerously oversimplified? Because I'm just going to take to the core of the ACES. I know it seems overwhelming when we are talking about color management, because it's like, oh, color science. And as soon as it's science, you think about maths and you start thinking about your trauma from when you were young and the maths because you wanted to be an artist, not to talk about maths. And then you come to a conference to talk about maths. So no worries much. So I'm going to start talking about why ACES is actually super, super cool. And as Juan said before, many people has been working for so long and very talented scientists, colorists, and many people in the industry just to create the ACES. The ACES workflow, that sounds like a super complex system of many things. It is in the technical level, but for us artists, it's actually very, very simple. So what I'm going to demonstrate is I can show you what is ACES and all you need to know for ACES in half an hour. So let's start by why ACES is really the future. ACES is not the only color management system that we can have. I mean, there are many others, but it feels like it's the future. Everybody is using that. So as everybody in the industry is doing the same thing, it's much safer just to invest into a pipeline that is managed by ACES. So what is the points that are important? Well, the image resolution. So you can use any image resolution. You don't have any kind of restrictions. The frame rate is the same. We don't care about the frame rate. The color that you can manage in there. Well, if you can see it, ACES can manage it. And that is very important. So you have the whole visible spectrum into the ACES workflow. So that's why it's future-proof, because I guess we are not going to see more colors next year. I mean, even if technology is getting better, our eyes are hopefully going to be the same. The high bit depth, we are going to use 16 bits half float, which is, I mean, pretty good, the standard for handling linear files. In terms of dynamic range, something that is a very hot topic these days, because you know all productions now are getting high dynamic range. Well, ACES can handle the high dynamic range. You can handle approximately something like 30 stops. And just for you as a reference, the human eye, they say that you can see something like 24 stops. So this can get even more than that. So that's why it's going to be the future. I mean, even if we develop the technology, this can handle everything. So this is, you know, in a nutshell, what is a workflow, a color management for in Nuke or any other platform. You have files that you get into the software, and then you get it to show somewhere. And then in here, you have files that are going somewhere else. Right now, this is just for you to have an overview of what we are going to discuss. So if we are going to talk about color spaces, the first thing we need to know is what is the odyssey of the color spaces that we have in here. So this is the chromaticity diagram, okay? This is roughly representing the colors that human beings can see, okay? So those, I mean, the organization and stuff, that is technical stuff that you don't need to know right now. But this is representing the colors you can see. So there are two different kinds of color spaces. This, for instance, this set that is represented in here, a few of them, is the display refer color spaces. It means that those color spaces are representing what you can see in certain displays. For instance, the super famous sRGB, mostly, or computer monitors are sRGB, or the Rec 709, that is for TVs and all of that. And the new, very famous Rec 2020 for HDR, or the DCI-P3 for cinema projection. Everything in here is for displays. That's why all those color spaces are within the visible spectrum, because it wouldn't make sense that you create colors that you cannot see. So that's why you are getting all the values within the chromaticity diagram. But this is for displays. There are other kinds of color spaces. There are the color spaces for the cameras for capturing the light. And we can see certain colors, but we know that there are other animals that they see other colors, for instance. Well, cameras are other animals that see other colors yet. So there are all those color spaces in there, and there is even the red-white gamut that is even getting up the screen, so it's out. So you have all those color spaces for the cameras together with the color spaces for the display. So be my guest and start transforming from one to another. You can do it. You can apply lots to convert from one to another, and then from the other to another one, and then to another one, and then to another one. And sooner or later, someone is going to get it wrong, for sure. What I don't want is you to be the one that is going to get it wrong. And how traumatic can be this? Well, it can be if you are not managing the color well. Someone gives you the footage, you ingest the footage, you do the comp, you sweat, you die doing the comp, basically. That is mainly our jobs. And then after you have a struggle for your life, sweat, blood, and all of that, it gets to the laboratory and they say, oh, I forgot to mention, yeah, the color space was wrong. And it's like, no worries, I'm going to make the transformation. No. No worries, I'm going to start again. So you die twice for the same shot. That is not good. So that's why it's much better and safer that we have a code for everybody to work in the same way. So the color management, what it's going to do is just to ensure everybody is seeing the same color, but not just the same color, but the same color that the filmmakers wanted you to see, regardless the monitor or the display or the projector that you are watching. Yes, as Hugo said this morning, you are never going to see the same image because, of course, every display has a different capability to represent the image. But what you are going to get is the best approximation of that. Of course, if you are working with a monitor that you bought on Lidl, you get like 50 pounds or 50 euros monitor, don't expect too much of that. So it's going to look wrong. But if you get like a calibrated good monitor and another good calibrated monitor, even if they are different, they are going to look very similar, okay? So that's why we are going to need the color management. Well, for ACES, we are going to simplify things a lot because we have in ACES mainly two different color spaces that are referred for us. So they are VFX focused. It doesn't mean that they are the only one. But the first one that we need to know is this one. That is delimited by the primaries. The primaries are those points that you have on the corners. The triangle, you know why it's a triangle? Every vertex of the triangle is R, G, and B. So R, G, and B. Okay? So you are containing and mixing the positions in the intensity of those. You can get a position in there. Well, look at this. It is really interesting because this triangle is actually containing the whole spectrum. Every color that you can see can be contained in here. Okay, so this is the main color space for ACES. Is the one contained in the 2065-1 color space. It's a very long name that you can refer to that as AP0. Okay, so this is the main one. This is the standard. ACES, everything that is in ACES and exchanging by ACES is in here. Why? Because you are not going to miss anything. Then there is another color space that is specifically designed for us visual effects artists. This is the ACES CG. That there are many reasons why this is smaller. If you compare this with the Rec 2020, it's very, very, very similar. And in here, you have, in difference with the Rec 2020, the Rec 2020 is actually a display color space. This is not. In here, you have even a little part in the top that are colors that you cannot see, but yes, it's a mathematical thing that you need in order to get the rest correctly. So this is the color space that is going to be used for Nuke, for instance. When you are working in Nuke, in ACES, this is the color space that you are using in the workspace. So what Nuke is doing the calculations. I don't know if you know that unless you specify the color management, Nuke is not managing the color. Nuke is just whatever you fit in there is just linearizing things using the linear light fashion. So it's just taking every step of light intensity and just put it in there. But it's not managing the color. There are no primaries, for instance. In here, when you are applying the color management in ACES, actually, Nuke is taking every image and is placing the image, in terms of the colors, inside that color space. So everything is going to be absolute in absolute terms. Every coordinate of the color is absolute. So that's why it's very important. As I said before, there is not just one working space, which is the color space used for handling the color. So there is the ACES proxy, the ACES CG, ACES CC, and ACES CCT. The CC and the CCT is for colorists. Okay, so it's not is logarithmic. It's not for us. We need to work in a linear fashion. So this one, the ACES CG, is the most important for us. It doesn't mean that we are not going to use the other, the big one, the A-bit0. But when we are handling things, everything is going to get in there, especially when we are generating renders. So the question now is, how can I make this work? Well, how to make it work is just about transformations. So ACES has a system of transformations that is standardized. So everybody, regardless the software, is going to use the same transformations in the same way. That's why we're going to look at the image in the same way. Because if we apply the same transformation, the same maths, the same algorithms, so everything is going to be looking the same after the transformations. So now, I think it's time to understand the transformations. So the ACES color transformations, now is when we are going to start going deep, okay? So be careful, brace yourself. So this is the workflow for ACES. It's actually based on 3 steps of transformation, so it's not difficult at all. Once you know what it is, I assure you that by the end of this conference, you are going to know everything that is in here. So IDT, LMT, ODT, what is that? Well, it's a transformation for entering into the ACES workflow, another for exiting from the ACES workflow, and another in the middle to create the look or to apply the look that someone else already created. So where we are in here, visual effects artists, compositors, we are in there. So we are going to work with the images from the raw. That camera file is just the raw, so nothing applied to that. When it's ingested into the ACES workflow, we are going to apply what is called a IDT. And then just for that, we are just going to start working with our files. Then depends if we want to visualize in the viewer, and of course you want to visualize in the viewer, you cannot work with that, you need to apply certain other transformations. So in order to make it easier, I'm just going to explain one by one these transformations, starting by what is the meaning of the letters. So the first one is the IDT, the Input Device Transform. The T at the end is always transform, so it's really easy. Input Device Transform. So the purpose of this transformation is to take you from the camera color space, doing blah, 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 and you get it into the ACES. That's simple. And I know, oh my God, should I know maths about that? No worries. It's seriously one button in Nuke. It's really, really easy. But if you don't know what the button is for, you cannot do what it needs for. So this is the input. Every camera has their own input device transform. Who is the best person to create that? Well, the manufacturers. So Arri is going to create the IDT for their cameras, and Canon the same, Blackmagic the same. So every manufacturer is going to create their own way of transforming from their camera, that nobody better than them knows the camera, into the ACES color space. There are other exceptions that are not coming from the camera. For instance, the scan, film negative scan. There's still people doing films in scans, as Christopher Nolan, for instance. And then you have, for instance, I don't know, photographs from cats, from the Google, I don't know, whatever. You want to put something from Google, okay, you use another IDT from converting from, I don't know, sRGB into ACES. So there is, for every color space, there is a IDT. So you can get from any image into the ACES workflow. So this is the door of the ACES workflow. Then let's go for the next one. If we have the one to enter, now let's go to the end, the one to exit. So we went from the camera color space into the ACES color space, AP0, remember? So now what you need is to go to a screen, certain screen. Can be your monitor, can be a projector that you are working with a projector, can be to the iPad of the director because he wants to watch that, I don't know, your phone. Any screen in the world, you need a transformation from going into the managed color space of ACES into that device. Well, that is the ODT, which is the output device transform. So it's just that. And it's standardized. So every kind of display or every color space for that display is using one ODT, so you can just get the right one. I don't know, P3 or sRGB, Rec 709, Rec 2020, anything. Anything can get with the ODT. So now that we have the beginning and the end, we just need the middle bit, okay? And this is very versatile. And actually, this is really, really important for artists because it's not just about getting inside and getting outside. It's what is in the middle. So if I want to see things as the filmmakers were looking at in the set, for instance, you know that the cinematographer usually works with the DIT to find certain LUTs on set. So they apply certain color corrections to show in the monitor the intention of the cinematographer. So those alterations of the image, those transformations, are going to be stored in certain files. For instance, the most common is the CDL, the color decision list. So it's just a file that is called CDL that is just storing 4 values and a saturation. So it's just a few parameters. It's very simple. And just with those parameters, you can reproduce the same as the director and the DP was visualizing on set. So that is the first. So let's do now the whole workflow, and let's play with that. So the camera files get into the ACES. So this is from the ACES, and at the end, it gets the ODT to go to the projection system, dailies, I don't know. So what can we do? Well, the first thing is, as I said before, the compositing is in this stage. How many people in here is not a compositor? Well, no worries. Nobody is perfect. It's fine. So the compositing is done, as I said before, with the IDT. So you don't need to apply the visualization. So you are working with the raw material. Okay, it's not raw because it has been transformed, but it hasn't been alter. So nobody has been applying color corrections to that. That IDT is just for getting into the ACES color space. So we work with that material. So what can we do with the LMT? So the look modification transform can be used, for instance, for a CDL, as I said before, something like applying the color that the director of photography was applying on set. But then, after that, some colorists like to apply what is called a first light. Okay, so you can apply also after that another LMT that can be, for instance, an emulation of a photochemical processing. For instance, bleach bypass that in the 90s was going really, really good because Spielberg was doing that with Save Private Ryan. Okay, that is, for instance, another procedural color correction that you can apply. And after that, someone can say, I would like to apply also a preset, because I have a preset that I created for another show. For instance, I don't know, Day for Night or something else. So you can even interchange from one project to another color corrections, LUTs, because at the end, this is like a LUT, and you can apply into this system, because the maths, as I said before, the maths are going to be absolute to the color space. So everything is working and interchangeable. The order is important. So you need to reproduce always the order, but that can be also embedded in the metadata as well. So everything has been made to keep the consistency of the workflow. And then another example, for instance, is to create like what is called a trim grading, trim pass. That is when you imagine that you are doing your grading for HDR. And then you convert everything from HDR to SDR, so Rec 709, for instance, for DVDs, I don't know. And from there, you need to make one adjustment to the whole thing. So that is another look transformation. So this is what I mean. You can apply as many as you like. And you have many different kinds of files that you can use. OpenColor.io supports many different files, and the new version even more. That is all that you need to know about the LUTs. So once you have that, you get through the ODT, and you get the full workflow. So what is this part that is on the pink rectangle? This is what is called the creative intent. So everything that is in here is what the filmmakers, that can be the DP, the director, the colorist, whoever is having a say in the look of the image, is actually creating this. And you know what? You can visualize this in the suite of the colorist, or in NUKE Studio, for instance, or on set, if you, just the first one, or if you have this and you have a colorist on set, you can apply the whole thing on set, because this is like a fixed structure that you can reproduce. So it's very versatile and very easy, and it's way more difficult that you get an error because it has been standardized. So that is the creative intent. So in here, what is the ACES workflow? So the ACES workflow is this. It's from the IDT to the ODT. So from the in to the out, with everything in the middle. Okay, so that's why when we are doing the compositing, we are actually in the middle of the thing. And you can decide, because this is a funny one, you can work in a project that is, the full project is ACES based. So from the set to the delivery is ACES, or you can just decide to start the workflow of ACES just within the visual effects. So you receive whatever you receive, you transform into the ACES, and then when you deliver, you get and deliver whatever they want. It's the same as you do when you are not managing the color space in NUKE, but with the certainty that anybody across the departments in the visual effects company is going to see the same thing. And that is actually very important. So ACES is great for keeping consistency and preserving their artistic and creative intent. Okay, so that is the big deal. The only thing that is missing in here is what happens when we need to exchange files with other companies, with other people, with whatever. There is also a standardized way of exchanging, because what's the point of having a very standardized set of transformation if then I deliver whatever I like? No, no, no. There is one very standardized group of transformations and stuff that is really, really important. So it's the ACES compliant EXR file. So it's just an EXR that is just having certain features that must be embedded in there. Nuke, by the way, is simplifying all of this because you just need to put a color space in there. We are going to see that, by the way. I'm going to have a practical demo, so you see that. I'm going to do that in real time, and it's really, really fast. The things that you have to keep in consideration for the ACES compliant EXR is that it's an EXR that is one frame per file, of course. You can store RGB or RGBA if you like, so the alpha also can be inside. And you can use it for mono or for stereo, so for stereoscopy, or even for more than one view, so it's multi-view. Then, the bit depth, the amount of bits that we are going to use is always the same. It's 16-bit half float, okay? And compress. The color encode, so the color space that you have to place in there, is this one, ACES 2065-1. No worries, it's very long, but it's very standard. It's the AP0 that I was talking about. So the AP0, that is the name of the primaries, the color space is named like that. And no worries, because Nuke is using that standard, of course, to name that file. Something to keep in mind, when you are exchanging the ACES compliant EXR, that ACES compliant EXR cannot have embedded any LMT or any ODT or anything. It must be exactly like in the beginning, the IDT. So you cannot apply any transformation, because if you are going to destroy the information. So the ACES compliant must be in the color space without any transformation, except the one that is putting the data inside, so with the IDT. Then you need a set of metadata, okay? This is very scary, no worries. It's just one checkbox in Nuke. You don't have to write anything. But that checkbox actually matters, because allow other softwares to understand that that file is ACES encode, so everything is going to be standardized. If you forget the metadata, even if everything else is going to be compliant, the software may not know that is ACES, so that can create the issue. So now that you are an expert in ACES workflows, let's check how to create the ACES workflow. And you are going to see that now you are going to understand the graphic that I put in the very beginning. It's really, really easy. So let's start by the color space that we are working, the workspace. The workspace is the color space that Nuke is going to operate the functions and every operation in there. So what is the workspace in Nuke when we are handling the color for ACES? Well, is the this one, the ACES CG, this one here. Remember AP1? Okay, ACES CG, that is the workspace in Nuke. How do you do that? It's just those two arrows. You go, you put color management, Open Color IO, OCO, and then the OCO config, that is going to be ACES 1.1, for instance. This is very, very important, so let me have a break on this. If someone is using a version of ACES and you want to keep the consistency, you should use the same version of ACES. That, for instance, is embedding the metadata. But even safer is just ask, hey, what version are we using of ACES? They are going to tell you, okay, 1.2, 1.3, 1.1, whatever is the version. You put that in there. You have a few that are standardized, and you can, as you can see below that, there is a custom Open Color IO config, so you can actually put in there whatever you like, if you are using like a discontinued version or whatever. So the rectangle that I put in there is just to showcase that the working space, even if you don't have to touch, because none of the default LUT settings that you have in there, you need to touch them. But it's just to show you that the working space, as soon as you set the OpenColor.io config at the ACES, it's just going to become ACES linear. ACES linear is the ACES CG. So every time before you were saying, oh, give me the files in linear, give me the files in linear. That means give me the files in ACES CG. That is the new linear, okay? So that is for setting the environment. Now, once you have the files from the cameras, because of course there is always a director that wants to use his phone for having a take, you just need to apply the IDT. So the IDT, where is the IDT? Oh my God, it's just the input transform, formerly known as the color space. You know, in the read node, you have the color space. Now it's not named a color space anymore. It's input transform, okay? So you just need to make sure in the input transform, you are applying the color space of that camera. So if you are using the ARRI, for instance, the ARRI Alexa, in this case was the ARRI V3 Log C, the Venice is going to be, I mean, each one is going to have their own. If you are unsure, just go to the manual of the camera or go to the website, and you can even download if you don't have it, the input transform. But no worries, because the guys at Foundry have preloaded in there the most famous cameras that we are using, okay? So this is the input transform. It's just in the read node. You go there and you click. That's it. That is the input transform, okay? So now that you have your images from the cameras into the color space, that is the first transformation. Nuke is doing, and I'm representing that in that cogwheel that you have in there. Nuke is converting everything into the ACES CG. That is the workspace. But you don't need to worry about that. You just need to put the IDT, and Nuke is going to do his thing. No worries. So what is the next? Renders. If you have a render, think about it. You can do the render directly into the ACES CG. Usually, we want the renders to be linear. So what we do is just to create the render into the ACES CG, so you don't need to transform it. So you don't need to apply any IDT, because it's already in the workspace. But what if I have my renders in another format? Well, it's not a problem. You just put the right. If your renders are in sRGB, you apply the IDT for the sRGB. Don't do this at home if you are not in the presence of an adult that supervises you. You don't render in sRGB, please. So try to render in ACES CG if possible, and if not, you just apply the right IDT. So that is for the renders. There is another instance that is someone else have been working in those files, and they are providing you with those files. So what are they going to provide you? Well, they are going to provide you with the EXR ACES compliant file. So what you need to specify is that that is a ACES compliant file. So you just put that color space, the ACES 2065-1, okay? And that is all you need to put all your files inside Nuke. Once your files are in Nuke, you do your business with the files. But something that is important is that you visualize the files as they are intended to be visualized. How many times happens that you work with the raw footage without any LUTs, and then you work a lot, you blood, sweat, tears, dying in front of the desk, and then the colorist arrives and is like, I like it dark. Everything that you did is gone. When that happens, why? Well, because that is the intention. Well, that's why we want to see the intention of the director, because you want to be sure that what you are doing is actually what it needs to be done. If the colorist is just deciding to go very dark, you just need to pay a lot of attention in the lights and the other way around. So having the LUTs is just very nice. You can apply the LUTs in many different ways in Nuke. The LUTs are going to be applied using the OpenColor.io transformations that I'm going to show you in a bit, just to show you the nodes. I'm not going to enter in much, but for instance, this is the file transform. This is just any file that is containing color transformations. You have it in here. You just say what is the working space that was used for doing that. It should be the metadata. So you don't need to worry about that. And you just apply that color transformation. And that color transformation is just going to be applied for your viewer. So you are not going to embed that in the file unless they ask you, hey, can you please export a QuickTime for my iPad? Blah, blah, blah. Then you embed that. But if not, you can have it into the viewer, just that. So that is one of the nodes that you can use, the file transform. But you can use, for instance, the CDL transform. As I said before, CDL, color decision list. That is something that is very common on set. Others, well, you have the look transform, another way of applying. So all of these are just color transformations in different fashions, okay? There are more than that. So this is just an example. So everything in here is just a way of applying LMTs. Can be one, can be two, can be whatever, but it needs to be applied also in a certain order, okay? So that is for the LMT. So with that, we are visualizing the creative intent. But remember, we are working there, not there. We're working in the color space. So we are still working with the raw material, okay? It's not raw, it's just the raw with the ID. So once you have that, what you need to do is to decide where are you going to visualize that. You want to put in the cinema or in the monitor or in a TV or in a web. Those are the options available that you can apply in the viewer to visualize, okay? So for instance, if you are using a regular computer monitor, you want to use the ACES sRGB. That is the SDR, so non-HDR content can be displayed in there. If you want a projector, like in here, this is a Rec 709. If you have a monitor, for instance, I'm using an Asus ProArt PG32 UCG that is a multi-format, I can visualize different formats. So depending on what is the configuration that I'm using in the monitor, I can just put that in there so I can visualize in any of those and make sure that I can reproduce certain color spaces. So make sure you know your monitor because you need to understand what is the color space that you're using with. So this is for visualization. So you are going to use the ODTs that are embedded already in the viewer. Once everybody is happy and you are already alive because you have finished your work, someone has to deliver. Well, you deliver in ACES compliant EXRs. How do you make a ACES compliant EXR? It's seriously very easy. You just, in the output transform, that was known formerly as the color space in the grid node. Now it's called output transform. You just select that color space, which is the standardized color space for or EXR ACES compliant. And the other thing that you need to mark is that write ACES compliant EXR, just that. Those two things, and that's it. You don't need to care about the data type, the compression, because that is going to be blank now because NUKE is going to take care of that. So with that, actually, it's done. The files go, you are happy, you send them voice, and you get paid and rich with the pool and crocodiles and whatever you like. So this is actually the workflow. It's just a set of transformations because NUKE is taking care of everything else. The only thing that you need to care about is what is the file? Where is that file coming from? What camera? Well, you apply that, the right IDT. Once everything is in NUKE, you apply the LMT to visualize, and then you get, depending on the monitor that you are using, you apply a ODT. That's it. That is color management in NUKE for applying ACES. I know it sounds like rocket science, and it is actually. Behind the hood is a lot of people working, doing super massive complex things. For us artists, 1, 2, 3, and it's done. Okay? So if you want more information about ACES workflow and that, you go to the source, ACES Central. All the nice people is in there working, updating everything. And of course, now what I'm going to do is I'm going to do a live presentation about how to handle the color spaces and all of that in Nuke is going to take me 5 minutes. So just let me show you. Oh, I see this software before. So yeah, I think so. So this is Nuke. As you open it, nothing fancy. I haven't changed anything. So the first thing that you do, I'm going to put two different instances. The first one is I have the raw footage. So I have the footage directly from the camera. So the first thing that you have to do in your Nuke is open the properties of the project. You can go there, project settings, or you can press S in here. It's the same thing. Color management, open Color I/O. That is the first step. Second step, open Color I/O config. So you select what is the right. I'm going to select 1.2. OK, that's it. Now, welcome. This is ACES Manage in Nuke. Complex, eh? Now, let's ingest the data. So I'm going to get, from my desktop, this chart. This is a very old image, has been shot in red. So I'm just going to load the settings from the metadata. And now I'm going to get in here the color space. Input. So if you go in here, in the input transform IDT, you go in here, and you have several common use. And then in here, you have color spaces. You have the ACES color spaces. See that we discussed before, all this? Well, no. Not the output, because that is for monitors. The utilities that are for people with no personal life. And the input device transform. So you just check what is the camera. You need to know, I mean, come on, they are paying you. You should know what is the camera, the color space. If not, you just call the camera operator, or someone needs to know that. I mean, it's going to be embedded in the metadata, but come on, just write it down. So in this case, it's going to be red block. So that's it. OK? In here, what monitor are you looking at? Well, in my case, this monitor is sRGB, but this projector is Rec 709. So Rec 709, here you are. OK. Now you are looking at that in the right way and looking at this in the wrong way. You know what? In the new version of Nuke, you have different monitor outputs. So you can actually have an output for every single monitor that you have, and you can put the settings for that monitor into the right color space. So whatever you are going to look at is going to look right. OK? In here, I'm not going to enter into that because you have a life that you want to live. I'm not going to start doing that, but it's just to let you know that it is possible. So this step that I just did by placing in here the right color space, which is the input, red, oops, input, red. That is the IDT. That's it. From this moment on, this image is now linearized inside the Nuke workspace. OK? By the way, if you are doing this for only one file, maybe it makes sense that you do it in Nuke X. But if you are handling a whole project and you have like a sequence that have been conformed and everything, Nuke Studio has been designed specifically for that. So you can deploy even just applying very simply, selecting the project and applying the IDT for a selected range of clips. You can apply the whole thing to everything and then generate the files, the compositions for every Nuke session, and has been already set up into the color management, and everything is going to be consistent. Nuke Studio is a very powerful tool that is still, I believe, needs to be discovered, because as soon as you understand color management and you get more into that, you will understand how powerful is Nuke Studio. So that's why for right now, I'm just going to explain things in here because in NUKE Studio it's exactly the same thing, but it's having a timeline, okay? I don't like timelines because it reminds me of After Effects, so I don't like to enter in there. It's a trauma for my childhood. So no, it's fine. It's made for editors, so it's more for an editing environment, while I'm more pixel-based. So this is the way of importing raw material. But what if instead they are providing you already with material that is an ACES compliant? Someone is telling you that you need just to work with something that has been already converted using other softwares. But I'm going to do the same thing. So I'm going to get this this thing. Let me see the EVA footage. This one, okay. Okay. See that NUKE is telling me that this is scene linear. I made this on purpose just to showcase what happens when you don't write the metadata right. So there is no metadata that in here is telling me that this should be the ACES 2065-1. So this is going to look wrong. If you want to correct that, because you should know if someone is giving you ACES compliant file, you just go in there, and it's in here, the default ACES 2065-1. That's it. Now, that's it. It's very easy. I'm sorry to disappoint because maybe you were expecting me to do like crazy things, but it's just one button. So, and that is for that. What happens if you have like CG? Let's make the other example. This is like a beauty. So this is CG. Let me put this in input here. Okay, this is a CG that has been rendered in ACES linear. Well, welcome. I don't even have to press any button because it's already ACES linear. Why? Because NUKE has been designed to understand that everything that is linear is ACES linear. ACES linear, remember, is ACES CG. So if I change this to ACES CG, this one, you will see that the image in the monitor is not going to change. It's exactly the same thing. So when you hear in here, in this thing, default linear or scene linear is ACES CG. So that's all. You want ODTs. Here you are, the ODTs. I already make an example, so I can change from this. If you are projecting into a cinema, you go to the P360, the HDR, you go for the Rec 2020. So that is the game. Now, the only thing is you need to know where that file is coming from, where is it going. That's it. No more strange things. So I'm going to show you another thing. This is already done because I don't want to keep you here just looking at me comping things, but this is an example. It's a very silly one. This is an example of a workflow with a blue screen. And in here, I have this viewer input, okay? This is a group that is the input process. So I just create a certain transformations, color transformations that are going to be affecting how the viewer looks, but it's not affecting the values. So if I click in here, now I'm sampling this image. If I remove the input process, see that it's looking different? Well, the values are not changing. So the input process is just for me to understand what's going on. So let's see what is inside. And here you are. Open Color.io CDL transformation. So I have a file that is in there that is just giving me certain transformations, and that is my viewer process. How do you do a viewer process? Just this is a bonus. Just go there, and you are going to see that there is in here input process. So if you have a node in your comp that is called viewer_input, everything that is doing that node is going to be applied just to the viewer. And by the way, this node is not connected to anything. You cannot connect it. It's just a node that is going to represent the process that is going to be affecting the monitor. So you can change the name in there. You can name it whatever you like. The important is that this name and that name must be the same. okay? So that is also the LMT. So you want more LMTs? Be my guest, I'm putting here more nodes. Where are the nodes for that? So in here, Open Color IO. There are more, they are hidden, but right now you can use these ones. There are more. I mean, there are ways of getting out. If you get me a beer in the bar, I can tell you more. So, but yeah, I mean, those are the ones that you need to know. You have color space transformation, display, so for the ODT, to embed the ODT, file transform, lock convert, that is like the lock to link, link to lock, famous, the look transform, the CDL, so everything is in here. Again, is Open Color IO, so is everything is encoded with the same platform. So it's going to look exactly the same way if you encode it in here on any other software, okay? So with this, as I promised, now you are experts in color management.